Thank you. It's really a pleasure to be here with you guys. This is such an interesting program, meeting new friends and new colleagues. The title of my presentation today is Light and Language, Media Archaeology in Latin America and History of Computing and the Arts and Media. Okay, so here is the starting point. These are some of my important areas of interest, history of computation in general, when people invented, in some cases people say discover computation in history. That's already a very important and interesting problem, how we historicize one field like computation, right? How we tell that story, or those many stories about like the history of computing. What is necessary to do that, right? Like, do you need to talk about programs, data? But also one very important thing to me is when and how people started to use computers with creative purposes, right? To create art, to criticize things, and situations like that. Additionally, I've been working in the history of media in Latin America for a long while. And at the beginning, I can tell you, I should confess that I thought these two interests were parallel and kind of they will never touch each other, right? Despite, of course, I consider the nature of computation a very important part of the media, of what media is. I didn't found at that time case studies to illustrate that connection. Today, instead, I'm going to talk about several findings in that direction that interconnect the history of computing and the arts in the history of media in Latin America. It's the first time I'm talking about this in public in such configuration. So I'm doing that because I know you're clever people working in similar things. I need your feedback to take the arguments and really try to grow up with this point, because I think there are a lot of interesting things here and several interesting problems. There are like key aspects of the research that I usually do. The first one is I'm very interested in the description of the technical apparatus, right? Precise as possible. The reevaluation of the relationship between innovation, invention, and priority, especially when we discuss things like who invented what, right, and when that happened. One thing that really amazes me is that almost every time I check for technical creativity, there's somehow intertwined one experiment with artistic creativity too. So when you find these kind of deep creative processes in the technical sense, especially when it's connected to media and sometimes with the history of computing, you also find creative processes. That is kind of what I'm going to talk about in one specific context. That leads to our next element of my perspective is the relevance of the geographical and cultural contexts where those technologies were produced or emerged. And the last thing is that whenever possible, I like to have an experimental approach. Either use the technologies, either reconstruct the technologies in order to have kind of a hands-on experience with those technologies. Wendy was talking about one very interesting concept that is like experimental philosophy. And I would like to follow because seems that eventually can help me elaborate about this process in a deeper way. So just to make sure that I pay credit to my influences, I can say that I'm not the only person working in kind of such research. There are like other researchers doing that in a better way in many aspects, like Irene Medina, professor at MIT, who wrote this book, Cybernetic Revolutionaries, History of this Proto-Internet System in Chile, that we mentioned in the sessions already. The book by Rubén Gallo, Mexican Modernity, about like the implementation and the use of radio and photographic cameras in the 30s in Mexico after the Mexican Revolution. And this book by Eduardo Cac, Luz y Letra, that talks a lot about the history of the relationship between technology and the arts in Brazil, which is really phenomenal. As I'm involved in information visualization, I try often to create visual representations to help myself, and find a map where I can locate myself and my journeys, right? So we were talking this morning about some of the case studies I follow through my research. Here in the y-axis we have geographical places and the change of those geographical places in time, like Mexico was the new Spain and before the Aztec Empire, and then in that particular region I can locate several case studies, like for instance the history of cybernetics in Mexico, right? That happens in between the end of the 40s and the 70s, which was incredibly important for the definition of cybernetics itself, not just for, let's say, one chapter of cybernetics in Mexico, but in general terms, right? So here, it's exactly my journey, right? Like how I started to write a dissertation about these topics. I choose some of the chapters, the ones that I was able to identify primary sources. That is like definitely makes a huge difference when you started to work on this, and I was able to afford traveling to these countries to find the information. And while I was doing that, at the same time, I was trying to make sense of the evolution of computers and when and where the devices were invented. So this is probably new for you now. So we are talking about probably the earliest example that we have documented on one machine that is considered a computer is the analytical engine in the 1830s, 1840s. And Ada Lovelace, as you probably know, already mentioned the possibility of composing music with such a device. That device was not fully constructed, just like the central unit was built. But you can go and see that in the London Museum, for instance. But the golden decade of the construction of computers worldwide is between the 30s and 40s. Like many interesting things happen there. And some of the most important processes happen in Germany, right? Like, let's say in 1936, Konrad Zuse, one person that I followed with care, constructed one mechanical programmable computer, arguably the first working computer in the 20th century, okay? And he built a version of it that was electromechanical between 41 and 42. That's probably the first programmable computer ever made that worked with electronic means. It was electromechanical because it used to work with telephone relays. And we have many others, right? Like the Colossus in the UK, IBM Harvard Mark I in the States, ENIAC later on, Manchester Mark I, one computer in Australia, and so on. So I've been trying to create this map, this timeline of the evolution of computers, but at the same time trying to identify which is my actual topic, which is the relationship with these computers and the arts. And you can discover that from the beginning, the arts are present, which is a remarkable thing, right? So the analytical engine is related to music. Ada Lovelace talk about like the possibility of composing music. Actually, the punch cards they use came from the textile industry that was also an art form. The Z1 and C3 machines made by Zuse use punch film stock to store the data and the programs. So that interconnects this story with the history of cinema. And then later on, computers like the Manchester Mark I was used later on, like an evolution of it, to write the first experimental poetry in the UK. And here is the thing, right? Like computers like the Xerac in Australia was used as early as 1949, before any commercial computer was available worldwide to compose music. With a very poor interface to create the sound, that's for sure. Beep, beep, beep was kind of the only thing, but they were able to make structures and make the computer to play those musical structures. And we are going to focus now, let's say, in the first two examples that relate to Latin America. So the first one is called Photoformas and happened in Brazil in 1949. So Photoformas, so let's see some of the machines. This is the analytical engine in the UK, Science Museum. I was very interested exactly in these devices, you know, my theory of culture. The punch cards are here. Different punch cards for the data and software. It was not binary computer. It was based in powers of 10, so it was like complicated to build. But this is the, you know, central unit. This is the Z1, the mechanical computer that SUSE made in the 30s in Berlin, in the living room of his parents' house. Spare time, you know, trying to understand some things. And the fact that really blew my mind at that time was the fact that punch film, recycled punch film, was used to store the data, right? And the programs. And he invented the system to punch the film itself and later on the system to read it and read it back the program, right? So here is where my history, let's say, of interest on cinema and computers started, right? Because I knew about the materiality of this thing. I knew how flexible it was, where was it produced. This is like a, you know, company in Belgium producing this that was like widely used in the 40s in Germany. It's flexible. It has like this, you know, little holes that help you to place it in a very precise position and things like that. He didn't have the need to go to paper, for instance, to do that. So that's a remarkable thing. And for a long while, I've been trying to make sense of the processes that Konrad Zuse sparked, right? Another thing that is very important, so we have, you know, the Z3 here in the 41, then in the Z4 came in the 46, that was like the first commercial computer that he tried to make. But in the 45, he created Plan Calcul. Is that German? That sounds like German. So that German word is the first high-level programming language. And I've been interested in the artifacts, but then now I'm more and more interested in this abstract thing that makes those machines as we are, machines of language, which is kind of a remarkable fact, okay? So, where's the philosophy to interpret that? It's difficult to answer, but I will try to give at least some examples of case studies that can spark some questions. So, just to show you how complex were the things in the same time, in the 49, this is the computer that was built in Australia to do many things, and it was used to compose music, okay? Just to show that, you know, many things happen in different parts of the world. Let's talk about Photoformas now. 49, Brazil. What happened is the following. Geraldo de Barros is a visual artist from Sao Paulo. He works part-time in his own studio and part-time in a bank, okay? That detail will be important later on. He is incredibly talented on taking new devices like a photographic camera, an amplifier, things like that, and make sense of them very quickly and try to push the boundaries in the creative process using those devices, you know. He takes the photographic camera and started to take like several pictures in the same negative, right? Like overexposition, for instance. And he mastered that. He did like a fantastic series of photography. One thing that is really important, talking about the materiality of film, is that he started to produce these abstract photos at a time. And what he did was the manipulation of the physical negative, drawing, scratching, cutting, changing the position of fragments of the negative to achieve this fantastic kind of middle point abstract figurative images. Some examples with Scratch that will become later on very important in Canada. These are the negatives of one of the most famous photos that he did, you know, with the shoe, and then completing the image, scratching the negative, right? So the materiality of the thing was very important. And here's the thing. In the collection of Photoformas, there are like around 70 photos. there were in the collection like 8 photos that didn't have negative. Okay, that's the starting point of the story. So the daughter of Geraldo de Barros is trying to make sense where these kind of images come from. And it's a long story, but the short version is following. Geraldo de Barros was working in the bank. He got in contact with the people running the tabulators that were IBM machines, right? And he got back home punch cards that already use binary system to store data. And he used those punch cards instead of the photographic film in the enlarger in the darkroom. And he created these amazing photos that are very abstract, very repetitive, actually very similar to what people did first time with software with computers. But this is, illumination, light passing through the little holes in the punch card. But it's already a translation of digital information into a visual rendering. In this case, photochemical. Okay? So imagine this was like a performance inside the darkroom, right? Like he moving, the enlarger to get like a bigger and smaller projections of the whole, like the darker areas, covering part of it. And now these pictures became really important. The Museum of Modern Art in New York acquired this one, for instance. You can say it's one of the first manifestations, if not the computer arts, at least of the transformation of digital information into an image.
Is this part of the Photoformas?
Yes, that's part of Photoformas series. That's why we started with that, right? So this happened in Brazil, and there is more and more attention on his work, of course, as you can imagine. I had the opportunity to work with his daughter. She runs an archive in Switzerland, not far from here. And the attention that these images are getting now is like really prominent. I'm happy to be one of the persons writing about this to find like concepts to describe this. Because it's like, it's an oddity, but at the same time, it articulates all of our interests in creativity and machines, right? That it's an example of one person taking one part of the computational system, let's say, the tabulator, and eventually using that for artistic purposes. That's one example. Another example, between 49 and 51, this is demoniac. It's originally a machine built in the UK. We are very interested because it was the first computer that arrived in Central America, okay, in the 51, 52. And it has like a particular configuration, and later on that was the inspiration for a very important work of art. And we are exactly in the same point here in the 49, okay? Remember, here we're in a point where interaction with computers only happen through even punch cards or tape, right? Or punch film. There is no screen, there is no mouse. Barely there's like a speaker, right? In the cases of computers like this one. So, the output is super limited and the input too. So we are talking now about the monetary national income analog computer. I don't know if you heard about it. It's the invention of one inventor from New Zealand. He comes all the way from New Zealand. He's an economist, sinologist. He's an expert on China. He's an inventor. He's very famous in economics because of the Phillips curve. That is one thing that articulates inflation and unemployment. But when he arrived to the UK, he started to work in a machine that can model the national economic process of the country. And he did it, right? And he built a computer to do that. Just that this computer is not like any computer that we know. It's a computer that runs with water, right? It's like electronic circuits are circuits of electrons, traveling and getting condensed in some parts. Some of those principles of circuits, and liquid and so on, are also applied to the fluid dynamics, right? So he was able to generate a system, a computer that actually can calculate, all the components of the economy in the UK, and actually have like some variables that you can change, and eventually can see like the changes in one aspect of the economic variables, and then the result of the entire thing, right? So to explain that quickly, this is the representation of the system, right? All started here in the transactions and balances of the entire country. Then the income goes up, like literally as pumped water. And if you want to go to government, the tank that represents government, it goes in the form of taxes and comes back as investment, or can go to the bank, for instance, as savings, and also the water can go to investments too. And to tweak this variable, investment taxes, you can actually move the variables, like the physical elements, to change the results. For instance, this is the tank for foreign trade, and you can, of course, put some money as imports and take some, the money back in the flow as exports. This is the entire economic system. Imagine this, one computer made entirely with water in the 40s by a guy from New Zealand. So today, we have like some of these computers in Melbourne. I know like Francesca is going to Melbourne now, so I will drop her an email to go and visit this machine. This is the entire system. It's not working, right? But it's the entire system. And one thing that is really important to me right now is that this is being the inspiration to one of my favorite artists, Michael Stevenson. He's also from New Zealand. And he's been doing research about the fact that in the 52, this machine, one of the 14 machines of the MONIAC, the versions of the MONIAC, arrived to Guatemala at a time, right? In the middle of a very liberal government at a time, who was trying to make sense of, economic system in order to allow like a agrarian reform and things like that. Like super impressive, an example somehow related to the cyber scene context. And he's been, these days, doing reconstructions of that machine. So the machine in Guatemala is lost. I've been there twice looking for it. There's no physical trace of it, but there is like a lot of evidence of the people who saw it, some pictures and so on. And Stevenson is like an artist, but at the same time he's a researcher on the history of technology, and he made this functional reconstruction of the computer called the Fountain of Prosperity, right? But he adds a lot of interesting twists. So, because he reconstructs that, if the machine is being functional since the 50s until now, so it has like some kind of, broken parts, some parts are fixed with, just one string and things like that. So it's like partial, functioning like not really properly, like criticizing kind of the implementation of these big economic systems in countries like Guatemala, okay? So this is another oddity, right? So this is one computer created in the 49 that waited for a long while to be transformed into an art piece, but actually the view of one artist doing this kind of reconstruction illuminates us about many things, including the nature of technology and how computing arrived in countries like Guatemala, right? Or Colombia, if you want. Do you know his work in general? He has other works with, let's say, other pieces of technology from New Zealand, like cars. They started to produce cars in one moment, and they failed. And that failure, he pays attention and does like installations about it. It's remarkable work too. So we had one example from the 40s, one from the 50s. Now in the 60s, between 66 and 68, we can start looking at some technical inventions that actually happened in Latin America. There's this computer or like proto-computer called Catalina in Argentina in the 68, and it's the work of one inventor called Fernando von Reichenbach. As you can imagine from his last name, he's from German origins. And I was able to identify in his exhibition some of his inventions, right? Like he did like this system, for instance, to run musical pieces in 4 speakers at the same time, trying to control how the sound travel. And he built a lot of interesting equipment, like a sequencers for sound, like this, like, sampler system to mix things. He was super active. I'm working on a research project about him now. But the most interesting thing that he developed is this thing. In the 67, it's called Catalina. It's a system, attention to this, using a television camera. The television camera was looking at the paper here, and composers used to draw on top of this, and there was like a transduction of these graphics that you can see here in these 2 monitors into sound in real time. Say it again? Not now, but we can. I can send you samples. It's unbelievable, and it's pretty well documented. Probably the only piece by his invention that is very well documented. But beyond the device itself, and here is the thing: if you go to the description, what is he looking for? It's even more illuminating, because what he sees this system is as a programming system. So he understands that writing here, in a visual way, he can actually create a sequence that the system will interpret, in a linear way that is actually similar to what we call today programming, and he used that word. So it's like just a visual language, right? So and I think these ideas of transforming graphisms, eventually text later on, into something that is interpreted by one machine is at the core of this performative element of programming languages that we can start like anticipating here with this technical creativity applied to these problems. Even more, in the 71, right, one friend of Geraldo de Barros in Brazil, Valdemar Cordeiro, produces what are called today the first computer art pieces made in South America, right? And he uses code again. He was in contact with, he was working with an IBM machine. He got like an IBM, it was like a new machine, relatively small, and he was able to produce this, very early in the 70s, is the first one of this sequence of actually computer art. And again, it is done like with ASCII characters. It's kind of also like the transformation of kind of language into image, right? It's different from other experiments in computer graphics at the time because it has somehow the photographic view attached to it. It's not just, squares and lines, let's say, right? Or curves. These are another examples. People is just one fragment of a computer output in 1972 at University of Campinas, the interior of the state of Brazil, of Sao Paulo. And he was associated with one computer center at the time. Brazil incorporated in education very quickly computers that were used like people like him. His pieces are just remarkable. And this piece is probably the most important piece of computer arts in Latin America. It's a work by him. It's called The Woman Who's Not BB, right? The Lady Who's Not Brigitte Bardot, right? Like talking about kind of representation of women in media already, okay? That's, outstanding in my opinion. It's very strange. More important for our context here, he was part of New Tendencies, okay? These exhibitions in Zagreb, not once, like several times. He was part of the movement, right? Same thing with the movement in Argentina in the 72, Arte y Cibernética, Art and Cybernetics, first uses of computers and computer graphics in Argentina. They created one public exhibition in 72, but they started working before. They actually created a group with that name, Arts and Cybernetics. They got in contact with the computer technique group in Japan. They inspired them. They sent some of the pieces, and actually they created this fantastic exhibition with many artworks that today are just the foundations of several experimental artistic practices. One of them is this example. It's again, the transformation of written language into visual code. And it was kind of interactive piece because people need to memorize kind of the things and then go back and forth and find the clues and kind of interpret the codes that were printed there in other papers like this one. Beautiful piece. This is like one booklet that you can take, with you and actually, be in the exhibition and still like be deciphering, decoding the messages there. So as I told you, this is mentioned several times in one book like this one, New Tendencies, by Margaret Rosen, who will be probably your professor here. So you are so lucky. And in general, if you want to read this, it's just an outstanding piece of research, rendered in a book format about this movement in Zagreb and, former Yugoslavia, but also around the world and many connections with Latin America. So they were the ones who, paid attention to what was happening there, Brazil, Argentina. But there's more stuff, right? There's more stuff. In the 72, in Chile, José Vicente Azuar, one composer, releases the first album on computer music called The Virtuous Computer. And he did what a transgender artist Wendy Carlos did, that is like trying to get some of the classic and experimental repertoire and make a computer to play that music back. Right? And here's again like this level of how you will transform the scores into computer instructions, right? That is another level of a written language that is like the musical scores and that is based composition, right? So for you to kind of understand this, where to place these kind of experiments in a more, let's say, traditional way of looking at the evolution of computers and computer arts, I created this timeline that explains here the work of Konrad Zuse, for instance, but now between the 80s and the 70s, and the relationship between the creation of the graphomat, that was his fair plotter, that was actually used by the two pioneers of computer graphics in Germany, Nake, who is professor here too, and George Ness, who is an outstanding artist, working with computers. All of them later on went to a conference in Madrid called Impulsos. Other artists like Jens Harke later on started to use also here in the German context or nearby. New Tendencies is located here, right? Around like the 68, sorry. That happened in Zagreb. This was like more Stuttgart, right? That was Berlin. And then we have what was happening in London around cybernetic serendipity. Several of them, of course, exhibited their work in cybernetic serendipity. Some of them were related to New Tendencies, but they didn't exhibit their work there. And we are talking about like a kind of new tracks, I'm simplifying a lot what happened in the States, but let's say we can mention that Michael Knoll, as early as George Ness, probably a little bit before, using other kind of plotters, they started also the computer graphics and computer art movement in the States. And more or less in this part of the timeline, we can find the computers like Catalina, the artworks by Mar Cordeiro, the experiments in Argentina, Arte Cibernética, and the Virtuous Computer, which is pretty early, right? Like this New Tendencies book that we check is like about this time. And of course, this is an invitation for you and to see how we can account of these stories. What are the concepts that we can really find to articulate and contrast these different kind of families of computer arts, taking place in the world at a time. I'm positive there will be another examples in other parts of the world. Let's say I am working now in a timeline, part of the timeline that includes the Japanese, computer art group that we just mentioned, for instance, right? Like it's coming from Asia, and I think it's the necessity to enrich this perspective. Some of them were connected, some were not. So that, it's very important to mention not just like the artifacts are the artists, but also like the mobility and the mobility of concepts and publications. So a little bit after that decade, between 60s and 70s, in 78, before any personal computer arrived in Chile, again, Jose Vicente Azuar engages with the task of creating his own computer, his own personal computer, right? And it is a very important distinction. For the album El Computador Virtuoso, he needed to go to one place, to one computer lab at the university to work, at night, of course. A lot of caffeine, right? And then working at night, programming and so on. There. But here, he wants to have this machine under his roof, right? And that makes a huge difference. So what happened is that he gets the first board that Intel produced massively. It was Turing complete, so it was like the possibility to make it really work like a computer. He erased the thing and started writing first in machine language everything, like the firmware of the thing, then the operating system, and then the interface to create sounds and also to render graphics, like at least text, okay? From scratch. Following no instructions, but his knowledge and experience with the PDP-8 that he used before. This is the album that he released in the next year in the 79. It's called Así habló el computador. That means like those spoke the computer, like those spoke Zarathustra, something like that. And can't be a better and nicer a cover, so colorful, and this mix between this technical thing, the music that actually is not like tropical, but this spacey, colorful, psychedelic thing is, expresses really well the times. What is important to say about his work is that, as I told you, he got the Intel 8080, one of the first microprocessors produced by Intel. He then took that and decided to, develop all the other components, got some timers to create like the sounds. Originally, he got like square waves, and it was here the system to process the information. He built all the hardware, right? Like obviously everything is dependent on the clock of the computer. Then he developed one system to get like the signals that are like square waves and make them in an analog fashion, softer, nicer sounds, or kind of curve, waves and things like that. It's not just the squares. He writes papers about it. He writes like an entire paper in Revista Musical Chilena, describing step by step how he built the computer. And this was the 5th paper he published in the field of computer music in that same journal, right? So it's a remarkable thing in many aspects. This is him working at the time. This is the monitor, the keyboard to compose all the analog components to, add filters to the sound. This is him when we had the opportunity to have an interview with him. He's dead now, unfortunately. But his entire purpose was composing music, right? And he made a very important musical pieces. He won the Bourges Festival, for instance. He got the award there. There's like an important music competition in France and others in the States. But things get more and more interesting. How much time do we have? I lose track of time. 10 minutes? 5 minutes? 15? Okay, that's 10, 15. So Let's go back to language. So in Colombia, there's this artist, Gilles Charalambos. He's from French origins, and his family is from Greece originally, with Edgar Acevedo, who is a Colombian who lives now in Switzerland. He's a programmer, he's an artist. He gets involved with the art and language movement in England. And he goes to live in England for a while. And there in England, he gets this piece of beauty, which is the Sinclair Spectrum CX. I don't know if you're familiar with this. I have one of these because it's just a thing. And I can add, they are releasing these computers again to connect to your mobile phone or tablet. So, and it's like for 70 pounds. So if you're interested in this kind of devices, you can get one back. And the good thing is that it has a video output, right? So you can do like a simple programs, relatively simple programs, and eventually export as video. And these artists who were like very into language, art and language, created the first pieces of computer arts in video in Colombia, using this language, like a text processor that you could like kind of program to create these kind of pieces. Very experimental, but it's actually the origin of experimental video using computers in Latin America, and it happened in Colombia. This guy was my professor. He was famous for other things, and then when I discovered this, I said like, hey, Gilles, we need to talk more about this. And I was able to do like an interview deep in the thing, how they made it, how they got the computer, why it was important to work with language to do this thing. And here we go back again, right? Like kind of we are in the same domain of the pieces Valverde Cordero, right? Like it's not like a plotter drawing, it's like images made by a little piece of information that reminds like the alphabet or the ASCII code. But in this case, it's kind of poetry that is mixed with some kind of criticism of society at a time. So my argument is that this creative relationship with language and media, especially computation, in those moments, prepare the field of the emergence of programming languages in Latin America, right? So I don't know how familiar you with programming languages, but I can tell you there are like a couple of important things to say here. Developing programming languages is an incredibly difficult task, okay? You can place yourself in the map, right? Like learning programming, let's say processing, it's challenging, right? Let's say mastering one language like that is challenging. Eventually, if you're a good programmer, eventually, processing is not enough. You need to switch to a language like it's more basic, like C++ or Python. And then eventually you can add, if you're very good, you can add libraries, right? Like to one particular purpose. If you're super good, eventually you can add a couple of lines to contribute to the language, let's say, core, right? But the task of designing one language from scratch is just super difficult. It's a very interesting philosophical problem, right? It's a very interesting political problem because in many cases, the use of languages determine where you can run or not your code. And the software studies field that eventually is the one that needs to be talking about this, it barely talks about computer languages, except for distinction between them. What is the distinction between object-oriented, procedural programming? But actually, this thing that makes, computers machines of language needs to go through this process of creating such a language, and that language needs to work. That's the thing, right? That's the programmative side. You execute the code. Or one interpreter, like a browser, interprets the code, and then you see a website, right? The website is the interpretation of the browser of HTML, PHP, CSS, JavaScript. So there are some examples in the 90s, in 94, in Rio de Janeiro, at the Pontificia Universidad Católica de Rio de Janeiro, there's one group called TechGraph Research Group, and they work for the oil company in Brazil, and they need image processing. And they see that several of the languages they are using for image processing, it's limited, and it's not fast enough, or they cannot embed the code in, kind of simple machines to create like control of things, right? So they decided to write first the entire specification of one language called Sol, that means sun, and that worked for a while, but eventually some people, and it was like kind of, a language to work in the lab only. So some people told them, hey, these languages look very powerful. Eventually, you can take those languages and make it more available, document properly, and it can have an impact in the world. So they decided to go and write Lua. That means moon in Portuguese, right? It's not like it's Lua, it's the name of the moon. And there's a fantastic book that tells the story of the invention of this language and the impact, that is written by a Russian researcher who lives in Canada. So this is, the global network already working to decipher this. This is Rio de Janeiro, where the language comes from. The book is called Coding Places, Software Practice in South American City. And he says that this brilliant language was invented kind of in the wrong place. That's his argument, right? Why I'm studying Rio de Janeiro when I can study, let's say, Silicon Valley? And Yuri Pakteyev, I don't know if he's been here or not, he wrote this book, was published by MIT Press, tells the story and the power of the language, right? The programming language. So just to mention a couple of things that people did with this language. So this language is very light and can be embedded in equipment that have, like, let's say, small chips, not that powerful. So it was very important in the origins of, let's say, smartphones. Some of the first applications of smartphones, several of them, used code in Lua to run. Like, have you played Angry Birds? Angry Birds, it's in a very important part, runs in Lua language. Because, needs to be executed in the telephone. And that's something that needs, like super pristine light code to actually work. I'm not going to so much details, but it has like a very simple syntax. Print hello is just this, right? Like print hello, and then, not colon at the end or something like that, not print that, in a complex fashion. Functions are defined like really in a very simple way too, and this simplicity made the program incredibly powerful. It's so interesting that if you don't know it, but you guess how it can be like one instruction, if you think in the simplest way, you usually write about how that language is structured. Of course, you can have functions. If you have functions, you can do procedural, that's the other thing, or object-oriented programming. You can do both in the same language. How many of you are coders? Okay, so what language do you use? C++, Java, okay. Python a little bit, or scripting. So this goes in the kind of scripting side, okay? Like let's say JavaScript, that kind of system. So I had the opportunity to interview them, and it's a super interesting group. They are mathematicians mainly, and one expert on computer languages, right? They travel the world now because the language was so successful, especially for video games and embedded applications. And And they receive, these days, one international visitor every week to ask them, about Lua, because it had like a strong impact in the open source community. So you go there to visit them in Rio, and you're gonna visit these, leaders of the free world, open source, and so on. And eventually they're like super, like kind of straight guys with, like very elegant, and they speak with wisdom all the time. It's such an interesting experience. Like they are like the gentleman technologist in the version from Rio de Janeiro there in action. 3 people incredibly smart designing things. I'm gonna conclude mentioning another example that is related to Colombia and also to Italy that also includes one language that is called wiring. You know Arduino, right? You know that the Arduino, when you program Arduino, you are using a language, and that language is called wiring, okay? And actually the history of wiring is very interesting. It was originally an input and output board, and also a language to program such an input-output board, right? What we call today just a microcontroller. This is the first image of the board that was produced. It was created in Italy, in Ivrea, in this school of design in Ivrea, where Olivetti used to run and used to produce computers in the past, okay? This is Hernando Barragan, the guy who created the system. This is the first board. This is the latest board that he produced. But the most important thing, in my opinion, beyond the board is language, because the language was portable. And you can program this board, but eventually other boards, and that's what's happened with Arduino. Arduino is a version of wiring compiled for another chip, okay? That was cheaper than wiring. And when you program actually the Arduino machine still today, you use the wiring language. And there were like many interesting things. Let's say the abstraction of a pin that in principle in electrical engineering is like another process. They just said, okay, let's identify one pin, and that pin can be input or output, and that's all. And that is of communication, trying to simplify the processes and transform that simplification into a instruction in the code, kind of change the entire way how we communicate with little microcontrollers, because these days kind of everybody is programming an Arduino in a way or another. Like in high schools, in universities, artists are using a lot to explore these machines, to explore physical computing and so on. And the good thing is that Barragan was working with Casey Reeves, who was the guy who created a programming language called processing, right? Like a simplified Java system. And he took the structure of processing to create the structure of the code in wiring. That is the language to program the Arduino too. So it has like a void setup, Here it's assigned the pin, like in principle it's just one instruction, identify the pin. Then it's an output instruction that is going there. And eventually we have this another function that is like a loop that is gonna be running permanently, right? This happens once for configuration. This happens, again and again and again. And this is like sending every second, computers count time in milliseconds. It's like 1 second. It's gonna be high in the LED pin, and then this is gonna be low another second, and it's like 1 LED blinking. That simplicity transformed entirely like the field of computer, physical computing and interaction. He did an even wiser thing. He created this website, emulating the structure of the processing website with all the information about the language, like how you create a structure, how you process data, how are the instructions of input-output, and this simplification of input-output is super important. And all the other things, like the mathematical operations you can do, calculations, and so on. Even more, for every single example of the specification of the language, he created a practical example. first in code, and then with instructions for electrical engineers who are able to read this language, and also for people like me, for instance, who at that time didn't know how to work with these things, how to pretend that it was a resistor, like a graphics to interconnect the thing. Just, a complete, the language implementation, the documentation of the language itself, then the transformation of that language into the performative code, and also visual representations of that, how to make it work. This is an example that I used a lot. It's about like one ping, right? Like one sensor that you can use to create like one kind of terming thing. And eventually it's just this simple code, right? You get like the sensor, specifications for engineers, or if you're not, eventually you just make sense of where is the board and connect that. He spent 2 years doing this. Imagine creating each example, only that, right? Like the cable and everything was just remarkable. At a time, I was able to contribute a little bit. I created the first example with an interface of wiring and C++. It was good for me. Of course, the wiring board, it was not sustainable to produce. He came back from Italy to work in Colombia. Producing the boards is really expensive in Colombia. He tried to produce them in Canada. It's also like another problem. Produce physical things in electronics is difficult. Competitors in China creating like cheaper copies is big competition. He released the website. Here's one common friend in the website. And for a long while, kind of people forgot, because of the huge success that Arduino had, that actually behind Arduino was this wiring thing, that with the board and also with the language, and that actually the language was developed by another guy. But luckily for Nando in 2013, there was this open summit of open hardware in Boston, and the case of the attribution was the point of the entire conference, and why Arduino didn't credit it properly, even though it's like a fantastic platform and it's open source and so on. They didn't really give credits to Hernando. So you can see here like a part of the people working for Arduino and also Barragan, and it became clear that to the public that Arduino was in fact based in wiring, and actually they recognized that publicly, okay? Later on, many things changed. The Arduino team split. I don't know if you follow that. They had like a big fight. And in the middle of that big fight, the new owner, that is the owner of Red Hat, I don't know if you know like free operating systems, like Linux operating system, Red Hat, acquired Arduino, and he brought Hernando Barragan back to the team, which was very good. He's Massimo Banzi from Italy, and the other team from the States and Spain. So there's, this little anecdote that locally for this project now, there's like better recognition of the origins of the language and the board itself. And what I want to say is that if we are confronted with the challenge of making sense in a cultural level, that is kind of part of your task, of computers, we need to confront the problem of languages. Right? And what I think is that in Latin America, we have a rich history of examples of kind of performative, poetic uses of language that eventually we can find a flexible way to understand language, and eventually those tools that were in some cases very close to technological developments help us to build tools to understand these kind of codes. Or languages, because the problem is, like software studies usually focuses on data, focuses on structures and algorithms, but the problem of language, which is very important, is left behind. In that sense, the book that I mentioned yesterday by Warren Sack, the software works, that places the origin of computation in the arts field, in the grammar, rhetoric, and so on and so forth, I think is like an illuminating path to explain that, but we need to go even deeper in the technical dimensions. So that's all that I want to share today in this short presentation. I hope it was clear, the structure and the examples were relevant. I'm here also asking for your help in the sense that you probably have pieces of information that eventually can, or references that can illuminate this discussion. I'm trying to open it here. I just want to add that for me it's very important, like the methodological process to engage with these problems, but you will see it's not an easy task when we are confronting to these problems. Primary sources is very important, right? What is the primary source when you are dealing with computer languages? The implementation, the sketches, the first code, the versions. That's such a problem now that GitHub opened it. I don't know if you have seen that, a particular chapter of GitHub just to the preservation of the history of open source software. Talking about preservations and museums. Just one entire chapter dedicated to that, right? Another important part, when the people available are live, interviews, check patents. This morning we spent a lot of time analyzing patents or showing the importance of doing that, right? If you're gonna today discuss Alexa, right? Go to the patents. You will find amazing information about those devices there. Sometimes we need to stop assuming what the technologies are, check the actual documentation of how they were created. Analyzing the devices, of course. Check archives. Believe it or not, now, as I tell you, there are archives on some of these points. In other cases in Latin America, one thing that is very difficult is to find like the archives of the documentation of these things. And sometimes I spent like 10 years trying to find one piece of information. That happened, for instance, with Azuar in a moment, especially the papers that were published in Revista Musical Chilena. I couldn't find those numbers. Finally, I got all of them in the States, right? Sí. So it was, but now are all online, so it's good, yeah. And then for the understanding of technology, I think it's also important, right? Like this twist to engage with practice. When it's computer languages, you need to learn them, at least like the basics, yeah, to see how they work, and eventually contribute to us re-signification of those languages, right? And that's all. I'm gonna conclude with one sentence that I usually use to talk about this. Is like one quote by Eduardo Galeano, one of the most important writers from South America. He said in one of very famous book that the goddess technology doesn't speak Spanish. So I'm going to challenge that. What I think is the goddess technology does actually speak Spanish or Portuguese or Russian. The problem is how we listen to those languages, right? And on top of that, I want to add that eventually it's not just a matter of the spoken languages, but about the artificial created languages that actually the computers use to perform their activities and processes. That's all today. Thank you.